Okay, so the first two say to solve and give a reason for each step. Remember that these can be done in different order, like it doesn't have to be the order that we're about to do it, okay? But as long as it has the correct reason, it would be okay. Where do you start, Santi? Go ahead.
So basically, so I added 5.
Well, what's the very first thing that we write?
Given.
Given, good. Okay, then you did what?
I added 5 on both sides.
So,
I have to write this out and work,
nope.
like, I added 5.
Nope. You literally would just write that next step.
Okay.
And then that reason.
I added 5x.
What's the property called?
Addition.
Addition property of equality. Okay, then what'd you do after that?
Then I added 38. And so again, addition property of equality.
Okay.
Then I divided by 8.
And?
Division.
Good.
And then I flipped them.
Did you flip them? Okay. You didn't have to, but if you did,
Homework.
I know it does. But like, let's just say if it was open-ended and you were done, like let's say it's an open-ended question, you're done there, I won't dock you points. If it's match something where you have to fill that in, like if the left side is done for you and you have to fill in the right side and it has that step, obviously you have to account for it. What's that called? When you flip it? Symmetric.
I did it differently.
How'd you do it?
I did like completely different. For the first step, I subtracted 3.
Okay.
Instead of added 5.
And then you put subtraction property of equality?
Yeah.
Yeah, okay, then did you subtract the 18?
Yeah, I subtracted 18.
Okay, and then divided by the
And
negative
divided
8.
by -8.
Okay, that's fine. All right, second one. You have to wait. What's happening today? Yeah, after when he's done. Negative 3x minus 5 equals 2x plus 10. That's given. Okay, who wants to start us off? What's one option for that first step? Come on. Distributive. Did you do both at the same time? Yeah, that's fine. As long as it's the same property used for both things, you could totally do them in the same step. So negative 3x plus 15 equals is 2x plus 20, and that's distributive property. And it could be sum or difference. It doesn't really matter because they're both one is the sum, but one is the difference. That's step 1. That's step 2. There are going to be 2 types of 2-column proofs. One in which they give you part of the information and you have to fill in, and another where it's completely blank and you have to come up with all of it. But again, this 2-column proof should to get you from the given to the proof, step by step. So reasons can be definitions. Okay, properties. We've done some postulates, but we're going to add to them. And we're going to add theorems. So like angle addition postulate says that the big angle equals the sum of its 2 parts. We did that yesterday. Segment addition postulate would say that the big segment equals the sum of its parts. So you're going to use things like that. And then you're going to use properties like transitive or substitution. And then definitions. So that's what this says. Acceptable reasons in a proof. The given information can either be given to you in words, like it will say given angle 1 equal or angle A equals angle B. That would be a given, okay? Or something from a diagram. So if you're looking at a diagram and there's a little right angle mark, you could say that that's a right angle, okay? Stuff that's provided from a diagram can be used, okay? Or any definitions up to this point, any properties up to this point, any postulates, and then the theorems are stuff that we are eventually going to get to know some theorems, which are things that are proven. Okay, by definition, a theorem is a statement that can be proven, okay? So a theorem is something that somebody before you came up with that always works, okay? It can be used in a proof as a reason for something. Like the Pythagorean theorem, you've heard of that before, that says a squared plus b squared equals c squared. That is like some mathematician, Pythagoras, that actually came before you, measured a right triangle over and over again and figured out the pattern of the sides and figured out if I took one side and squared it and added to the other side and squared it, it would give me the hypotenuse squared. So that is something that was proven before you even had to do anything, okay? Those can be used in proofs. So the properties of segment congruence says segment congruent is reflexive, symmetric, and transitive. So I can actually use either of those properties, or I can use properties of segment congruence as a reason. Properties of angle congruence say now the same about an angle. So if I had segment AB is equal to AB, okay, that's reflexive. If I said if AB equals B, well, let me pick different letters, equals CD, then CD equals AB, that would be symmetric. And then transitive, if AB equals CD and CD equals EF, then AB equals EF. That would be transitive. And then I can do all of that with an angle. So like angle A equals angle A is reflexive. Symmetric, angle A equals angle B if then angle B equals angle A. That's symmetric. And transitive, if angle A equals angle B and angle B equals angle C, then angle A equals angle C. That would be transitive.
Is symmetric one where they flip?
Symmetric, yeah, the order changes. Reflexive is itself. Think about looking at your reflection. Symmetric, the order switches. And then transitive is an if and then statement. So if one statement is true and a second statement is true that has a repeated part, you can remove the repeated part. So you're going to see these obviously built in two different ways, kind of like in the homework. You're going to get ones that are just a one statement thing on your test. Maybe it'll just say if A equals B and B equals C, and then A equals C, identify the property, and that would be transitive, or justify the reason that's transitive. And then you're also going to see them, which you'll see in a second, built into a proof in which you have to use them a step by step. All right, this is basically what we just wrote out, okay? The reflexive property for segments, so this first one is segments. Okay, like DE equals DE. For angles, angle D would equal angle D. Symmetric property, if DE equals FG, then FG equals DE. In angles, if angle A equals angle B, then B equals angle A. We switch the order. And then the transitive property for both are the if and then statements. If AB equals CD and CD equals EF, then we connect the two non-repeating parts, AB equals EF. And for angles, if A equals B and B equals C, then A equals C. Again, kind of take out the repeated part. All right, so here's what an example could look like if you're given, if you're given the left side. So it says, write the two-column proof. Given AC equals AB plus A, that should say AB plus BC. Oh, no, that's right, sorry. That's given. The actual picture is the other one. Yeah. AC equals AB plus AB, and AB equals BC, okay? Then go to your statement. So we're going to baby step our way into a completely blank one of these. It's going to give you the statements. You got to figure out the reason. So what is that first line? Where did that come from? It was given to you. So one is given. It is usually the first statement, but not always, because you can also base something off your picture first. like this picture. I could use that to make a statement.
You don't have to say given.
If it comes from the given, then you have to state given. If it comes from the picture,
You don't have to say given.
you don't state given, you state why you know what it is. Like look at 2. 2 says AB plus BC equals AC. Where did that come from?
The picture.
Why?
Because it shows A, B, and C, and it equals AC.
So think about what that actually, what's the name of that property or postulate?
Addition.
You're getting warmer. What says that the whole segment is the sum of its 2 parts?
Line push.
Segment,
Segment.
segment addition postulate. Now you're gonna learn it. Yep. Anytime that you're going from a diagram and you're saying that a segment is equal to the sum of its parts, it's segment addition postulate. So the challenge here is that now your book is saying not only do you learn what's in this section in this chapter, but everything that comes before this, you have to remember, okay? That's one of the big challenges of geometry.
So
All right.
3 would be what?
What?
What would 3 be?
3 says AB plus AB equals AB plus BC. How'd you get there?
I can see the picture.
Very close. So you took this statement, right? This part repeated, AB plus BC is here. But AC got replaced by AB plus AB. What's that called? When something is replaced by what it equals to? Substitution. This last statement says AB equals BC. What happened from 3 to 4?
Reflexive.
Look at 3 and look at 4. What changed? We lost the AB from both sides of the equal sign.
I mean, syllogism.
Nope.
What?
Subtraction. Good, Kala. Subtraction, property of equality. So from 3 to 4, we took away the AB that was on both sides of the equations, right?
But this is not an algebra problem.
You can still use addition and subtraction and multiplication and division on segments. All right, we're going to do it again. This time, what's given to me is that M is the midpoint of AB. And I'm trying to prove 2 things. 1, that 2AM equals AB. And B, AM equals half AB. So, start with the beginning. M is the midpoint of AB.
Given.
That's given. It's part of my given statement, right? There it is. 2 says AM equals MB. Nope.
Wrong.
Segment addition postulate would say that one segment equals the sum of its parts.
Oh.
Look at that. Look at the information you already know. Does AM equal MB? How do you know that? Okay, so we know it because we know the definition of a midpoint, and that's the reason. Definition of a midpoint. Yep. Yep. Yep.
How would I know
Is-
to write this?
You're learning, right? You're learning how to write this. That's a bad plan to start with. So if it's based on prior knowledge, which that is, if it's based on prior knowledge, then you have to say to yourself, how do I know that? How do I know that those 2 would be equal? And you know that because you know the midpoint means that it cuts it into 2 congruent parts. If that answer, the how I know it, is a definition, then that definition is your reason.
Wait, I have a question.
Yeah.
What is, it says equal, but then there's like a line on top.
That's just congruent. Remember, those are interchangeable.
Oh.
Yep, congruent and equals are completely interchangeable. All right, the third step says AM equals MB, and that's, we've now gone from congruent to equals, and if it would be the reverse, your book says definition of congruent segments.
Addition plus.
Not yet. So if you're going from equals to congruence or congruent to equals, then your reason is definition of congruent. It might say, like you're going to do drag and drop tonight in the book, it might say definition of congruent segments or definition of congruent angles, but that's really what it is, definition of congruent. Wait, oh, nope. If you're going from congruent to equals and everything about the statement is the same, whether I go congruence to equals and equals to congruence, my reason is definition of congruence. Because you should know that this little symbol means that they are equal, right? We know that because that means congruent, and we know congruent means equal. Anything that's based on the definition of a word, that's the reason. You literally say definition of that word. I promise you that these will get easier because you're going to start to see the things repeat. This first time is going to be scary, but you got to take a deep breath, okay?
So like,
Some of these things are going to be based on the diagram and the given information that are there, and some are always going to have the same kind of reason no matter what. Like if you go from congruence to equals, it's always definition of congruence. Whether I'm talking about angles or segments or triangles, whatever it is, if I'm substituting, if I'm switching out a congruent symbol for an equal symbol or equal for congruence, it's definition of congruence, okay? Now go to 4. 4 says AM, which if I'm looking at my diagram, AM plus MB equals AB. What are we saying there? That segment addition postulate. We are saying that one segment is the sum of its two parts. Segment addition postulate. Now 5 says AM plus AM equals AB. Substitution. We already said that AM and MB are the same thing, so we replaced one with the other, and that's substitution.
So are these like the only reasons?
Nope. Everything you learned up until now can be used.
Oh, but like these are the last ones that we're gonna learn?
No, like nope. Not even close. All right. You guys, 6A says 2AM equals AB. What did you actually do there? So what's weird is, yes, you're adding two things, but the addition property of equality says I'm adding to both sides of the equal sign, okay? So this we have not done yet. You are taking two things and you are combining. You are combining like terms there, right? And the way we say that is simplify. So if you are simplifying one side of the equation, you literally write simplify.
And for, oh, okay.
What?
Now what happened from 6 to 7? Division.
So you say division?
Yep. Division, property of equality.
See, that makes sense, but like...
All right. This is just some tips, okay? So it says in a proof, you make one statement at a time until you reach the conclusion because you make statements based on facts. You are using deductive reasoning. Usually the first statement in reason pair you write is given information, but we said it's usually that, right? But it doesn't have to come from that. So this is just an example where it says if you're given that angle 1 equals angle 2, you're trying to prove angle 2 equals angle 3. And I would never have gone 4 steps if they didn't give me 4 steps and ask me for the reason. So this would never be an open-ended blank one. But that first one is given. The second one, we went from congruence to equals. So that's definition of congruence. The third one, you switched sides. So that's symmetric. And the fourth one, you went back to congruence. So it's the definition of congruent angle, okay? Tonight's homework is going to have all the drag and drop stuff. You have to try them out. If you get a step wrong, try it again. You get 3 options, okay? But proof day 1 is never going to be the smoothest and easiest thing in the world. Some people, they just click, which is fantastic. But if you are frustrated, just take a deep breath and try it again.